Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, I hope to finish this course of Algebra 2 by going over the law of cosines, which is the only thing remaining, if I'm not mistaken. Usually, we use it along with the law of sine. So together, I really can find anything about any triangle. So if you give me some dimensions and others are missing, I can complete it. I can find the area of the triangle and so on and so forth. So what does the law of cosines say? The law of cosines says that in any triangle, doesn't matter what it is. So ABC, for example, so this is A, this is B, and this is C. For any of these sides, it doesn't matter which one you pick, A, B, or C, doesn't matter. So let's say we pick C. And I know this angle, right? Its angle C is known. So I say C square. Square? That reminds me of Pythagoras. Yeah, this is the actual law. And the Pythagorean theorem, as I will show you in a second, is a special case of the cosine law. Does it make any sense? Okay, let me write it down and then you will see. So usually we write c squared is, oh, I'm sorry, I wrote it like uppercase. No, it's just c squared, the side, okay? Equals a square plus b square. And if I stop here, you say, oh, I told you, this is Pythagoras. No, that's not the end of it. Minus twice a b cos c. What? So it's not Pythagoras. No, it is. How? Do you know that in Pythagoras, if this angle is 90 degrees and you're looking for c squared, you say c squared equals a squared plus b squared minus 2a times b times cos c. But c is 90 degrees and cosine 90 is 0. So that one hides. And you get the Pythagorean theorem. So really, we call it the Pythagorean, but it's just the law of cosines. Okay? Alrighty, but between this and between sine A over A equals sine B over B equals sine C over C, I can find any missing thing in a triangle. Sometimes I need only the law of sines, sometimes I only need the law of cosines, and sometimes I need both. Maybe since we mentioned that, let me show you also a very important formula that suppose for some reason I gave you these ABC, just the values of the sides, but you don't know any angle. So I can't use the law of sines because I don't have sine A or sine B or sine C. So how do I find those? And of course you can, but it would be so complicated. On the other hand, I cannot mention this or use it if I don't any of the triangles. How can I find the cosine of an unknown angle? So what do I do in this case? Here comes Heron to the rescue. Heron's formula. It says calculate half the perimeter, and let's call it S. I prefer to call it S. I don't know why. Maybe that's how it was presented to me when I was a kid. Is A plus B plus C, that's the circumference of this triangle, over 2. So you get this value. And then you say the area of the triangle equals the square root of S times S minus A times S minus B times S minus C. So now I can find the area of a triangle without knowing any angle of it in it. And between these three things, I bet you we can find anything in a triangle. Of course, you have to give me some information because you tell me, okay, I draw a triangle not to scale and I want you to find its area. Okay. Well, I'm not a magician, but I don't know. No, but I'm talking about, if you are given uh some information. When I say some information, for example, you can give me, for example, the three angles because I can draw this triangle, I can squish it and shrink it or stretch it. So angles by themselves are not enough. Give me two angles and a side, or two sides and an angle, or three sides. Yeah, I can find everything. Okay, so I have like 22 problems. Of course, we are not going to do all of these. And here, for example, let's see. The first four ask you to find a side. So maybe we do 1 and 4. And then in the next, you have to find one angle out of these six. So let's say right, left, left. And then we are going to solve triangles. I have four of them. Since we ended up in the right, I'll go left and then right. When they say solve the triangle, meaning we find everything like sides or angles, whatever is missing. And then here, it's the same thing. So let's keep going. That's too many. And then find the area so we can find the area of these two triangles. Hopefully these are 4, 6, 8, 10. Hopefully they won't take too long. Okay, I have my calculator. I make sure it's in degrees, not in radians. The first problem tells me find RT. I don't think you need me to write that, but I can, because let's write. RT square equals 23 square plus 27 square minus 2 times 23 times 27 times cos. Oh, I'm sorry, 15, not 27. Why did I say 23 and 15? I wrote the angle. 15 square, 15 cos 27. That would give me the square, so I take the square root. So on a calculator, you can say second square root of, and then you say 23 square, which is 529, plus 15 square, which is 225, minus 2 times 23 times 15 plus 27. 11.8. They want it nearest tenth, so 11.8. And they don't give me measurements, so units. It's not centimeter, it's not inch. Find ST. So without writing it down, I'm going to say square root of. They want ST. So 12 square plus 16 square minus 2 times 12 times 16 cos 54. It's 13.2. Now, something you should know, you may have known. Well, here it doesn't. No, I don't think that matters for now. Maybe I'll mention it later. Find the measure of angle A. I think in this case, the law of sines, I would use the law of sines, right? Because I know another angle. And I say, but the problem is here, I don't know this side. So I cannot say sine 107 over AB because I don't know AB. So maybe I start by finding AB. Sometimes I told you sometimes we need both the law of sines as well as the law of cosine. So I will use the law of cosine to find AB and then use the law of sines to find angle A. So for AB, I'm going to say it's the square root of 9 square plus 15 square minus 2 times 9 times 15 cosine 107, which is oh, oops, oh my God. I said times and I did divide, right? Minus 2 times, oh, okay, I'm glad I caught that in time. So this is 19.6. I don't need to write it. They didn't ask for it. It's already in my calculator. But I want to say that sine 107 over 19.6 equals sine A over 9. So to solve for A, I'm going to take the inverse sine. And then between parentheses, I say 9 times, or without times, I can say simply sine 107 divided by, and I don't type 19.6, I go to the actual value. Okay? And I get 26, just 26 degrees. Yeah, this is the thing I want to tell you is whenever you know the angles, we know that uh, the sides opposite to the angles are not in proportion, but if this is the largest angle, of course, it's more than 90. The largest number in largest angle in a triangle, then the opposing side must be the longest side. It's 19.6, which is more than 15, so we are fine. Okay? Sometimes we don't know that because I don't know the angles, but sometimes if you click the wrong button or something, you can not check your answer. It wouldn't tell you if your answer is right, but it would notify you if it's wrong. Here we have three sides, and they want angle H. Think about it. Give you a second, and then we'll do it. If you say the law of cosine, you would be right, because if I need this angle H, I go to the side opposed to that, and I say 22 square equals 26 square plus 28 square minus 2 times 26 times 28 cos H. Excuse me. When I move this, well, when I solve for this, I'm going to say, so this is negative. So if I move this to the other side and bring this here, I will get 26 square plus 28 square minus 22 square. And then I'm going to divide by to get cos H equals. When I solve for cos H, I would say 26 square plus 28 square minus 22 square divided by 2 times 26 times 28. You can do it on multiple steps. I just don't want to waste your time. You can check that later if you want. So to solve, I'm going to take inverse cos, and then I'm going to enter this value. So in the numerator, I open another parenthesis because this is for the inverse cos. I get 26 square plus 28 square minus 22 square, close the parentheses, and then divide by, open a new pair of parentheses, 2 times 26 times 28, close both parentheses, the one for that and the one for the inverse cosine. And that gives me 47. So H, measure of angle H, is 47.9 degrees. Okay? Since it's smaller than 60, yeah, it's possible. Why did I say smaller than 60? Because this angle has to be smaller than that and smaller than that. If it's an equilateral triangle, it would be 60, 60, 60. But if it's less than 60, that means that the difference can go to these two angles that would each of them be larger than that. And 47.9 makes sense. It doesn't tell you it's right, but it says it's plausible. If I didn't press the wrong button, then most likely it's correct. Again, as I said, you can do that on multiple steps. Take your time, don't rush. I'm just doing it quickly so the video will not be too long. I thought we had 10 problems. Alrighty, What is the measure of angle E? I still cannot use the law of sines because I know these two sides, but I don't know the angle opposed to that, opposite to that. So first, I'm going to use the law of cosines, right? The law of cosines to find this side. And then I'm going to use the law of sine by dividing the sine of this angle over that is the sine of the angle I don't know over that, like we did here. So I would say, or like we did here first, right? Which one? Can't remember. Yeah, I can't remember. So I would say FE square equals 20 square plus 30 square minus 2 times 20 times 30 cosine 59, which is roughly 1/2, slightly more. Okay, so I take the square root of this guy. 20 square plus 30 square minus 2 times 20 times 30 cos 59. 26.11. Larger than 20, so I expect this to be less than 59. Common sense? Okay, so I'm going to say 20, I'm sorry, well, it doesn't matter as I said last time. Sine 59 over 26.11 equals sine E over 20. So I will take inverse sine, oops, not inverse sine of what? This times this over that. So 20 sine 59 over this number. I'm not going to type it. I have it in my calculator. And that gives me 41 degrees. Measure of angle E equals 41 degrees if I need it to the nearest tenth. So I'm done with the top. I still have one problem here. They ask me solve each triangle. I have all three sides, but I don't have any angles. So I use the law of cosine to find either one of the three. It doesn't matter. And then the law of sines can help. I can apply the law of cosine 3 times, but it's tedious, right? I don't know. I think it's easier just to find one. Let's say we are going to find xy. So I'm going to say xy square equals 23 square plus 25 square minus 2 times 23 times 25 cosine z. Okay? But why did I say xy square? It's 26 square. Okay, doesn't matter. So again, when I move this here and that there, I can say that z equals r cosine. Again, you can check the numbers. It's going to be 23 square plus 25 square minus 26 square divided by 2 times 23 times 25. That would give me the angle. So inverse cosine, 23 square plus 25 square minus 26 square. Whoops, I forgot to add the parentheses for the numerator. I'm going to close this. Divided by 2 times 23 times 25. That gives me z equals 65.4 degrees. They don't care. Well, they do, because they asked me to find everything. So I found the measure of angle z. Then I am going to say sine 65.4 over 26 equals sine x over 23 equals sine y over 25. So to find x, I'm going to take inverse sine of, I'll do x. I can do either one, but I do x, okay? So it's 23 sine this angle over 26. So this is 53.6 degrees. Makes sense because the side opposite to x is smaller than that opposite to y. So the angle opposite to x must be smaller than. I can do this, repeat it, or I can subtract these two angles from 180. I have both. Let's do both to check our answer. So I can say, I'm going to take this guy, and instead of dividing by, instead of multiplying 23 by that, I'm going to multiply 25 by that, right? That's the only difference. Instead of, so I make that 25, and I get this 61 if I want one decimal place. Now let's say this plus that plus that equals 180 degrees. So I solved and I checked. Again, 65 is the largest because the angle opposite to z is the longest. Second is y, 61 degrees, because the side opposite to that is second in length. The smallest is 53.6 because the smallest is opposite to x. Another quick check. It's again, it's not a proof that you did it right, but the proof is that when we did it and then we summed up all the angles, we got 180. Sometimes you can get 179.9. It's still okay. It's just rounding in your calculator. Same thing, we want everything. Here I already have the angle, so I can say, I can find QR equals, so I'm going to say equals the square root of, because I can get QR square. Take the square root of 7 squared plus 16 squared minus 2 times 7 times 16 cosine 127. 20 or 21 since we need it to the nearest tenth. Okay? And you can see 21 is the largest side because the opposing angle is obtuse. It's the largest angle. Then we can say, as we did before, measure of angle Q equals, we get sine 127 over 21 equals sine Q over 7 equals sine R over 16. So to get the angle Q, I'm going to say inverse sine this times this, or angle Q, yes. This times this over that. 7 over 21 is 1/3. So I can simply say sine of 127 why I have that to delete this. Sine 27 over 3. So 8.7 degrees. Measure of angle R, it's 16 over 21. Okay, so inverse sine 16 sine 127 over 21. 37.5. Did I do this correctly? It doesn't seem it's correct. Are these? I said sine, inverse sine, 7 times, no, yeah, over 21. And that's the 3. This is 16 over 21, right? Okay, so we can check by adding the angles. I don't think, no, these won't add up to 180. I did something wrong. Someone help me. Help. I think because I said 21, it's not 21, it's really 20 point. I don't know if that would make a big difference. Let's get, oh my God, I deleted that. So let me do this quickly again. I'm going to say square root of 16 square plus 7 square minus 2 times 16 times 7 cos 127. Yeah, 20.97. Then I'm going to say 7, oh, I'm sorry, inverse sine of 7 sine 127 over this number. 15 point, yeah, this angle didn't seem correct. I probably 15.5 degrees. And then I'm gonna repeat it. And instead of the 7, I'm gonna use 16. 1, insert 6, that gives me 37.5. So now if I add this plus that plus 127, that's an important check, by the way. I got 180, so now I corrected my own mistake. Okay, in triangle RPQ, so you can draw any triangle. It doesn't matter, even if the angles are not correct. I'm just drawing a scalene triangle, and I say RPQ. Q, which is opposite to the angle, is 11. P, which is opposite to that, is 22. And the angle R is 96 degrees. Okay, so that's easy. I can find PQ. Again, the square root of, I hope you are not bored because you are doing the same thing over and over again. 11 square plus 22 square minus 11. That's why I'm trying to do it fast. Cos 96. I get 25.1. Makes sense. This is the largest angle. So the opposing is the largest of the three. Then I'm going to say to find a measure of angle, let's do P since P comes before Q. Measure of angle P equals inverse sine. I'm going to multiply the 22 sine 96 over 25, 25.1. Of course, I'm not going to use that. I'm going to use whatever I have here. So inverse sine 22 sine 96 over this, got 60.6. And angle Q should be the smallest measure of angle Q. Again, what I'm saying is, since I said sine 96 over 25.1, which we just found, equals 20 sine P over 22. So I multiply 22 sine 96 divided by 25.1. Now to find that, I'm going to use the same thing, sine Q over 11. So it would be inverse sine 11 sine 96 divided by the number I found here, 25.1. That gives me 25.8 degrees. So now I can add them up. This plus that plus 96. Uh-oh, Nope, I'm off by 2 degrees. Something went wrong. Let me check the length, 24. That's why I want you always to check your answer. So this is correct, right? Nope, it's not correct. I didn't subtract twice. I said 2. I said minus, oh, yeah. See, I did a horrible mistake. I subtracted just QR times PR instead of twice that. So this is 25.6. So now I can go back, say to this, and instead of, oh, no, it's easier, I think. Okay, I have this. So I'm going to say again, inverse sine. Again, I keep repeating, it's extremely important to check your answer and make, if you are finding everything, to make sure that the angles add up. So this is only 58.7. And then if I replace that by 11 instead of 22, I get 25.3. Now, this angle plus that angle plus the 96 degrees. Oh my God. No, no, no. Wait. How? We were off by 2 degrees and we dropped 2 degrees. So how come? No, 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 no. That doesn't make any sense. Did I subtract correctly? I said this angle. Oh my God. What happened? Plus 96. Why did it give me a horrible? Yeah, 180. Again, I pressed the wrong button. Guys, I'm so sorry. I'm really tired today, but I wanted to finish the course. In fact, I was recently, like yesterday, at the emergency room, but he said I just want to finish it. So I apologize. Find the area of the triangle, and this one, I have two sides and an angle. If I know this angle, for example, I can use the law of sines. Remember how we found the area of a triangle? It's 1/2 to adjacent side times the sine of the angle between them. That's what we did last session. So, but I don't know this angle. So what do? I have this side, that side. Do you see that I can use, if I use the law of cosines and I know two sides, I have to, as I said, I have to have this angle. So now I'm in trouble. But I can use the law of sines because I can say sine 72 over 7 equals sine of something, either f or d. Either I want f. Why f? Because if I know this angle and I have two sides with this angle between them, I can use the equation we used yesterday. So sine f, but I don't know the side DE. So I'm going to say over DE equals sine D over 4. So now from this equation, I can find sine D. If I know these two angles, I subtract them from 180 to get that, and then I can get, and then I don't need DE, in fact. I don't need it. I can just subtract from 180. So first of all, I say angle, the measure of angle D equals inverse sine 4 sine 72 over 7. 4 sine 72 divided by 7. And that gives me 32.9. Okay. So now I'm going to say 180 minus 72 minus this angle. Notice they didn't ask me to find everything about the triangle, just the area. So this angle, measure of angle F equals 75 degrees. Again, they don't ask me for that. However, once I know this angle, I say the area of the triangle equals 1/2 times 7 times 4 times sine of 75, which is the angle between them. So 1/2 times 4 times 7, so now that's 14 sine of this angle. I got 13.5 square meter. These are in meters. Everything else was units, just. And finally, I have the last problem. They give me 3 sides. It's tough. It's tough if you have to use the law of cosines. Well, not tough, but you can use the law of cosine to find any angle and then use this equation. Or you can use Heron's formula and you say S equals 9 plus 15 plus 13.8 over 2. It's 18.9. And you say the area equals the square root of 18.9 minus 9, meaning times 9.9, minus 15, so times 3.9, times this minus that is 5.1. S minus 9, S minus 15, S minus 13.1. So the square root of 18.9 times 9.9 times 3.9 times 5.1 equals 61.0 square yards. The second method is to find any angle. Let's say I want to find this angle. Just because these are integer numbers, right? So I'm going to say 13.8 square equals 9 square plus 15 square minus 2. Don't forget the 2 cos B. So I can find angle B as the inverse cos. And again, like I did before, I'm going to move this to the other side to become positive, bring this as negative. So I get 9 square plus 15 square minus 13.8 square divided by 2 times 9 times 15. Just to check our answer, I'm not doing it. We are done. Solve the problem. I'm going to check to see if we did it correctly because today I'm making too many mistakes. 9 square plus 15 square minus 13.8 square divided by 2 times 9 times 15. 64.6 or 0.7 degrees. So now the area equals 1/2 times 9 times 15 times sine of 64.7 degrees equals. Okay, so 1/2 times 9 times 15 sine this angle. 61 again. To one decimal place is 61.0. And that really concludes this topic, which is very easy. If you understand what you're doing, it's very simple. Combining the law of sine with the law of cosines, with finding the area using the sines, the product, 1/2, the product of two adjacent sides times the sine of the angle between them, or using Heron's formula, where you calculate half the perimeter and then take the square root of that number times the difference between that number and every single one of these sides. And that's a very nice and easy like formula to give you the angle, the area of any triangle for which you know the sides. I hope you had a nice time with this course. I did. I did. I love teaching, and I hope you learned something. I hope you enjoyed it. Um, as I said, after I started like posting the videos, in fact, before I post the videos, I noticed that I may not finish before the Regents exam. So I started to show like to upload two videos a day, one at 8 o'clock in the morning Eastern time and one at 6 p.m. And except for weekends because I may not be available. And I think we will be finishing sometimes like 10 days before the Regents or something like that. I didn't count because I'm still behind, like posting. Uh, I taped a lot of videos and I'm posting two of them every day, and this is the last one. I think this would be around like the 7th or the 8th of August or something. But nevertheless, as I said, there are a couple of back exams that I solved, and they are on they will be in the same playlist, and of course, you will see them. So please try those on your own. Check your answers. I think there was like a glitch in one of them, but I corrected it in a comment. Someone pointed it to me, and I did the correction. But other than that, they should be fine. Uh, as I said, I enjoyed having you throughout this course, and I wish you all the best in your exams. Thanks, and hope to see you in another course. Have a nice day.